Let's look at the halohydrin formation of this compound, methyl cyclopentene. And in this example, we're going to react our methyl cyclopentene with Br2 in water. Before we look at how the product forms, I want to look at the three-dimensional structure of our reactant, which I have a model of right here. You can see that the alkene portion of it is sp2 hybridized, is planar. We can look like this and see that these atoms are all in the same plane. The first thing that happens is this bromonium ion forms where the bromine is bridging these two carbons, the ones that used to be part of the double bond, and there is a positive charge spread out over the three atoms in this ring. The water is going to come in and it's going to react with one of these two carbons. The question is, which of these two carbons is it going to react with? Now, from a steric perspective, it might seem like it would be better for the oxygen to react with this carbon because it's less crowded at this carbon. But actually, that's not what happens. This positive charge, as I said, is spread out over the entire ring, and there's more positive charge on the more substituted carbon. That's why the oxygen will always attack the more substituted carbon in this reaction. So the oxygen with its electrons attacks this more substituted carbon because there's more positive charge there, and these electrons that were part of the carbon-bromine bond move up to the bromine. We can look at this in our three-dimensional model. So here's my bromonium ion with the bromine bridging the two carbons, and I want you to notice I've color-coded this hydrogen and this methyl group blue so they're easier to keep track of as we look at this reaction mechanism. And I want you to notice where the incoming water is in relation to the bromonium, the bromine in the three-membered ring. So here's our oxygen. It reacts with that carbon. These electrons move up to the bromine. And if we look, the oxygen that comes in is exactly opposite of the bromine that leaves, which means in our product, this oxygen that's going to be part of our OH group is going down, and the bromine is going up the way I have it displayed here. They'll be on opposite sides of the ring. And if we look at the product here, we can see that that's what I've drawn. The OH that came in from one side is going down in the way I've displayed here, and the bromine, which was on the top face, is still pointing up. My methyl group and my hydrogen, even though they were pointed in the same direction over here, one is now going up, one is now going down. And we can look at our product in three dimensions as well. So if we look here, the OH that came in from my water, I've left off the step in this mechanism where I lose the extra hydrogen. But if we look at its direction, it's pointed down the way I have it drawn here. The bromine is pointed up. You can see that they're opposite to one another. Likewise, this methyl group and this hydrogen, one is pointed up, one is pointed down. So the two important things to remember in this reaction are that the OH reacts at the more substituted carbon, and that the incoming OH group that is formed and the Br that we get in our product are opposite of one another.